When you're optimizing something, you're trying to find the best possible way to do something, right? And so that's what we're going to aim to do here. Before I move on, okay, I'm just adding a layer to what we've been doing. So you're like, why are we skipping all those questions? If you go to 57, if you just want a question and know how to write your inequalities and graphing it, 57 and 58 is one more go at it. And guess what this QR code takes you to? Takes you to a YouTube video. If you're stuck, it does it, okay? I tested it, they're still live, so use them if you need to, okay? So if you want to study for the test, it's still good. Even for the exam, it's still a good one. Except for now, I'm going to add the next layer, okay? So optimization questions. Basically what we're doing is finding the ultimate answer using objective functions. This is also new, but that's what we need to come up with the optimal solution, okay? So far, we were able to graph solution regions, solution polygons. They're the same of a system of inequalities, and stated the points of intersections surrounding the solution region. If the question asks for a combination, x, y, right, that will either maximize or minimize, right? So a combination that maximizes or minimizes something. It could be maximizing profit, but you want to minimize cost, okay? It is essentially asking to find the best answer. The best answer will come out of the POIs. There you go, one more time. It will come out of point of intersection, because you're kind of going into extremes at that point, okay? And one of those extremes is going to be our ultimate answer. To determine the optimal solution, the best answer, we need an objective function. I'm going to use a different color for this one. We need an objective function. It's not an inequality. It's a function, okay? Plug the POIs into the objective function, and this will allow you to determine the best combination. One more time. The objective function is not an inequality and should not be graphed. Do not make it show up on the graph, because it's technically done after you've graphed. Okay? Let's keep going. So let's say here, given the objective function, this is my objective function here. This is what it's going to look like quite often. Determine the optimal solution that would either maximize the output or minimize output. So you're looking for a combo, okay? What combo, right? That's what they're asking for. So in this case, this is my solution region. I have 3 POIs here, okay? We're going to plug it into this objective function and see which one maximizes. So let's see here. C is equal to 3, oh sorry, my bad, rewind. I'm going to show what I'm doing here. I'm going to take 7, 6 and plug it into that objective function. Okay? So I'm going to go C is equal to 3 times 7 minus 2 times 6. And C is going to be 9. Okay, that's 21 minus 12. So it's equal to 9. Then you grab the next one in no particular order. I'm going to grab 7, 9, 7, negative 9, and plug it in. C is equal to 3 times 7 minus 2 times negative 9. 3 times 7 is 21, and that's going to end up being positive 18. Okay, and that gives me 39. And then you grab your third POI, which is 21 negative 9. Yeah, 28 negative 9 minus, sorry, that is going to be C is equal to 3 times x minus 2 times negative 9. And so if you plug that in, I don't have that on my key, so I'll just quickly, 84 plus 18, and that is equal to 102. So I'm going to underline the 3, these are the outputs. There's 3 outputs here. So which one will maximize? Which one of these 3 POIs will maximize? Well, it's this last one, 28, negative 9. Okay? And which one will minimize output? It would be 7, 6. Okay, 7, 6 gives you the smallest output, so 7, 6 will do that one. And you got to know that down the road, for example, 7, 6 will mean something, right? Selling 7 pop cans and 6 hot dogs, right, will minimize sales or will minimize cost. As a business, you probably want to minimize. When it comes to profit, you want to maximize, right? Except for negative 9 is not an option for a word problem, really. But in this case, this is a non-contextual scenario, right? So you got to keep that in mind. Okay. So that's what we're going to be doing, folks. We're going to get it all the way to this point where we graph the thing, come up with the points of intersection, and then we're just going to have to plug it into our objective function to see which one is the best solution. Okay. All right. Let's try this here. I'm going to skip to a word problem. Okay. So come with me to page 61. When I set this up, I have some space there for non-contextual, but I don't know if you've realized that. That's probably why you either love or hate applied. Word problems, right? Some of you are like, word problems, I hate it, right? But that's what applied is all about. And that's what I actually love about applied, that you actually learn how to solve problems, okay? I can't solve your own problems, but math problems, I can solve those, right? Okay, here we go. You see that there's an optimization, a layer to this. Pay attention to this, guys. Nothing new. It's just one extra layer, okay, guys? So the first 80% is going to be exactly the same as what we've done before. So here we go. A parking lot has an area of 540 square feet of space available. Does that sound like an inequality to you if you were to read that? If it says space available, it's kind of saying how much room you have available. So that is actually an inequality right there, right off the top, right? Because you can use up to this much space. A car needs 9 square feet of space, while a bus requires 36 square feet of space. The manager of the lot does not want more than 45 vehicles on the lot at a time. The lot has a minimum of 10 cars per day, since there are people that work close by. Okay. A, state the variables and the implicit constraint. Let's do that first before we deal with the inequalities. Okay. What would you say the variables are? X, Y. It would be, in this case, the number of cars and the number of buses. Okay, those are the two variables here that we're wondering how many of those can fit in the parking lot. So X would be the number of cars, Y would be the number of buses. And we assume, we know, in fact, that none of them can be negative, so we go and state our implicit constraint. I also know this, continuous or discrete? Discrete. You can't have partial cars or partial buses, right? So let's do the hardest part now. Write the inequalities for the restrictions given. There's the restriction on space available, right? You cannot have more than 540 square feet taken up. Like if you need more than that, you're in trouble. There's not enough space. So what do we do here? I know that it's 9 square feet for every car, and it takes 36 square feet of space to park a bus, right? And whatever you do, however many cars and buses you let into the parking lot, it better be less than or equal to 540 square feet that is taken up, correct? Or else you're in trouble. That's the first restriction. What's another restriction in the text? Right here, the manager of the lot does not want more than 45 vehicles on the lot at a time. Okay? So there's a restriction on a number of cars. Is it specifically buses or cars, or is it combined? It's combined, correct? That's the idea we get here. How would we write this for $100? No, I don't have $100. X plus Y is less than or equal to 45. Okay? Cannot have more than 45 cars. Doesn't matter what you do here. But every time you come up with an inequality, you're restricting your answers that are possible. Let's keep reading. The lot has a minimum of 10 cars per day, since there are people working close by. A minimum of 10 cars. Sorry, you know what? Can I change? This is not correct. Cars is, you should do vehicles, right? Sorry, guys. Are you nervous, Mr. Erickson, or what? Maybe. Okay. Vehicles, so this is vehicles. And then there's a restriction on cars, okay? Just the number of actual cars. So that is specifically just talking about X, and you want that to be greater than or equal to 10. Boom, you've got your 3 inequalities. If you can do 3, you're in business with me, okay? You're good for the test. That's all I'm going to say. For graphing purposes. When it comes to writing out inequalities, it could be more. All right. We wrote the inequalities. Determine the combination of cars and buses that would maximize the profits. Given that a car pays $7.50 and a bus pays $25. And you have to say, hold it, like I need to solve this thing. So you need to graph it first and foremost. Okay, let's do that. This one is easy. Let's just do what we need to do right beside it. Let's start with this one. This one is going to be a solid line. Where's the true region? To the right, because it's greater than. I'm going to shade to the left. I'm going to shade the opposite. I'm going to circle that. This one is also fairly simple, correct? When you have one of those, what are my intercepts? 45, 0, 0, 45. If this throws you off, you do exactly what we used to do, right? Make that T chart, come up with your intercepts. Okay. You know what? Maybe I shouldn't be doing this. Maybe this will throw you off. I'm going to leave that there. There's nothing wrong with it. I'm just going to take this here. I'm going to solve this. X plus Y is less than or equal to 45. I'm just going to do my T chart because usually when I rush these, it backfires. 45, 0, 0, 45. You're writing this down, right? Then you rewrite it. So Y is less than or equal to, the X comes over to the right side, negative plus 45. That's it. Then you need to just tell me that this is solid. The true region in this case is below the line, the boundary line. I'm going to shade above the line. We're good so far? So I'm gonna block this off here. I'm gonna reserve this space here for my graph right here. I'm gonna reserve that. So I'm gonna do the work for the top one here, my very first inequality. I'm gonna do that on the bottom here, bottom left corner. So let's copy that down here. 9x plus 36y is less than or equal to 540. And so let's find the intercepts. Is equal to, oh, hi. Oh, I don't think so. You need me?
I can come back.
No, it's up. Is it going to take long?
No.
Okay. Okay, more days, guys. That's it. Okay. So I got the x-intercept. My y-intercept would be 36y is equal to 540. Y is equal to 15, right? I often like to pick whole numbers when I make these up. There you go. Let's rewrite it real quick. I'm going to try to do it right here. So 36y is less than or equal to negative 9x plus 540. Divide everything by 36. Y is less than or equal to negative 9 over 36. And I know this bothers some of you. Reduce it, right? That's okay. I'll just leave it like that because you don't get marks for it. So this is a solid line still. True region is below the line. Shade above the line. Okay. So this should all be just review for you. This part, the first section of this is just same thing. So let's graph this now. Grab a ruler. I will most likely give you a grid on the test, but still be comfortable with this. So I will try to use up as much as possible, but leave some space at the bottom here for the last part that we need to do. Okay, so this would be number of cars, number of buses, and I'm looking at my x-intercepts to see how far I need to go along the x-axis. The greatest value there is 60, right? 60, 0 is my greatest x value here. So I'm going to go to 60 or 70, maybe even 80. So let's see here, 10, 20, 30, 40, 50, 60, 70, 80. So I've got plenty of space. That is just fine. Okay. What about my y's? The biggest value on the y-axis is 45. So if I go up to 60, I'm okay here. So 10, 20, 30, 40, 50, 60. There you go. One at a time. One line at a time. Okay, so maybe I'll pick the easiest one, the 10 here. This is a vertical line, so you know it goes straight up here along the, it goes through 10, 0. So just graph it like that and label it right away. Got that one. The next one is 45 and 45. So 45 on the y-intercept and 45 on the x-intercept, also a solid line. Boom, right? call this x plus y is less than or equal to 45. And my last one is at 60, 0, 0, 15. So 15 is right there. Oh, now the labeling is pretty shady here. So you kind of have to navigate this carefully. So I'm going to redo this part. I'm gonna put the arrow to this one. Okay. And this one here, I'm going to label out here, and I'm going to call this 9x plus 36y less than or equal to 540. So that's fine to do that. Don't mix them up. And since you've told yourself where to shade, this is just a matter of just going through every line one by one and making sure you do this right. The vertical line I'm shading to the left. There we go. The this line right here I shade above. So that's, don't mix them up, right? That's this one. So you shade everything above that line. So just make sure there are no arrows, like the lines don't go past the X or the Y axis, okay? And last but not least, you also shade above this line right here. Okay, so notice how the solution region is going to be touching my x-axis, and that's fine. So everything above that line is gone as well. So we're slowly shading out all the wrong, the false regions. So just label it solution. So this is my solution polygon, solution region. Okay. Automatically, we're going to figure out what the POIs are. I'm going to write them down here. How many POIs does this have? It has one here, one there, one there, and one there. So there's 4 points surrounding the solution region. However, 2 of them are very easy. The ones that touch the x-axis we already know, correct? So this is, one of them is 10, 0, and the other one is 45, 0. You don't need to use your calculator for that one, right? So I just read it. This one I also just read off the graph. It's these 2 that we're going to have to find using our calculator. I wanted to do it right now because that's very important for you to be able to do it. So your task right now is to enter all 3 of the rewritten forms into your calculator and try to find these 2 points right now. Okay, it shouldn't take you that long. So I will just guide you through the entering process. Oh yeah, it's the 999, right? So whichever one you choose to do first. How about we go in this order? We do this one first, the very top one we came up with. So that's the -9/36. It doesn't matter. You will all get the same answer. And it's -x plus 45. And one more time, a vertical line. Do you remember the trick? You have to press 9 times. Followed by bracket x. In this case, it's positive 10 here. We're going to have to go minus 10, like that. I want you to figure out a good window Like, I want you to see everything. So you figure it out right now, try it before I do it with you. Okay. Actually write down the POIs that I want you. This one and this one. I want you to write something down. Make sure you use pencil. Time to work on one yourselves. And then I'll circulate. Okay, we need to find, whoa, my window is way off. So based on this grid, right, my X max should be 80 and my Y max should be 60. You could try zoom fit, you can try one of those. Okay, it's up to you. So I'm gonna go 80 here and 60 there. Let's see if that works. Yeah, that's a pretty good graph. So I want this point and this point. So second trace 5. I'm going to go between red and blue. So enter. It jumps to the red one. Perfect. Enter, enter. And you should see it land on the point you're interested in, which is this one. So that is 45. These ones are going to be worth more on the test, right? The ones you need a calculator for. And then we have to find this other one. So it's between the black and the blue. So it's second trace 5. I'm on the blue, so I'll just travel a little closer. Hit enter. You don't want the red one, right? So you cycle through until you get to the black line, and you will often not see the cursor. That's okay. Just hit enter. Enter one more time. And that's 10, 12.5. Does it? It shouldn't surprise you that it's 10, right? Because this is the x equals 10 boundary line. This is what we still needed. I used my calculator as well. There's one problem with this one. It's discrete data, right? So I need to make sure I round it. Okay, because it's discrete. So I'm going to actually highlight this. That's why I did that. Okay. So something like this would be 3 marks. I give you 1 mark for these combined, and then 1 mark for each calculator entry that you need to do to get it, okay? All right, so far this is what we've been doing all along. This is the new part, okay? Get ready for this one. Is there a blank page on your next page? 62 blank for you? Yeah? I think I inserted it for you, so I'm gonna, let's go to the next page for optimization. Okay, for C, we're gonna say go next page. Make sure you highlight that part. You tell yourself, I'm not done yet. This is the new part. Okay, so let's go to C, and I'm gonna do that over here. C. Write the objective function. Write the objective function. What is the objective function in this case? The problem gives you everything you need to write it, okay? Let's go look real quick. Yeah, let's go look what C is telling us. Determine the combination of cars and buses that would maximize profits, given that a car pays $7.50 and a bus pays $25. So this is what an objective function would look like for profit. Write this down, please. This is specifically speaking of profit. You would go pick a letter that you like. I will pick P for profit. The profit is found by going $7.50 for every car plus, and what is it? 25 for every bus. This is often a full mark, just writing that objective function. And now, plug in POIs. Pick largest value. Why largest? Because it says maximize, right? Maximize. So we're going to do that. 10, 0. Plug that into this. So it's 750 times 10 plus 25 times 0. That gives you 10. That gives you. Am I just doing? Yeah, this is 75. $75. If you pick the next one, which is 45, 0, that'd be 750 times 45 plus 25 times 0. So it's basically just 750 times 45. That's 337.50. So far that maximizes that combo. Let's keep going. 45, 5. That's 45 plus 25 times 5. And you can just type that into your calculator as is. Okay? So just go 7.5 times 45 plus 25 times 5. It will do it for you. That's 462.50. So far that is giving you the maximum income. And then last but not least is 1013. Even if your POIs are wrong, if you do this part right, you still get marks here. Okay. So that would be essentially 75 plus 25 times 13. That's 400. Which one maximizes? Oh, thank you. Yikes. Yikes. Let's see. Thank you. So it's 425. My bad. It still is the maximum. So that's the good thing. Okay. So change that to 425. So maximum profit when 40 and 5, not 45, right? When 40 cars and 5 buses are parked. All right. I'm going to give you the rest of the class to work through these types of questions. So here it is. Pages 63 to 64. This is optimization. So don't let that scare you. The first bit is exactly the same. I will already give you test review materials. Test review, page 65 to 66. And you can also do page 67 to 69. And the reason why I bunch it up is because there used to be different worksheets that I've just entered here. And so if you work through those, you will get ready for the test, all right? So work on 63 to 64, and I'll help you out. But make sure you get started today, okay? We're very close to the end. You just need to stay focused, all right, guys?